Hi everybody, this is Gigi from Kauai Community College. This is a practice problem in implicit differentiation section of Calc 1. Okay, so why is this there? Well, it's not even an implicit equation. So why is this in this section? Well, because the derivative of ln of x, if you were thinking about taking the derivative of ln of x, say y equals ln of x, and we want to know what is dy dx, right? So in order to find the derivative of ln of x, if it's something that you have not memorized yet, so here is how we take the derivative of ln. We would say if y is ln of x, then e to the y power is x, right? So now when we do go and take the derivative, it requires implicit differentiation here, right? So we would say the derivative of e to the y power, we know the derivative of e to some exponent is itself, so it's e to the y multiplied by dy dx, which is the chain rule, is equal to the derivative of x with respect to x is 1. So we would say dy dx is equal to 1 over e to the x. And e to the x is, e to the y, actually, e to the y, and e to the y power is 1 over x. So we will say that the derivative of ln of x is 1 over x. Okay, so that is the implicit differentiation concept here. And then in order to take the derivative of this function, which is ln of 2 divided by x squared plus 1 to the third power, well, we are going to apply this derivative here. So dy dx is, and this function is written explicitly as y equals, so we don't need to apply the implicit differentiation concept to this particular function on number 6 of your practice. However, we are applying the ln, the derivative of ln of x. The derivative of ln of x is 1 over x. 1 over x is the reciprocal, right? So say if the number is 2, the reciprocal is 1 half. And then if the number is 1 half, the reciprocal is 2 over 1. Well, here, let's say if the number is 2/3, then the reciprocal, which is when you flip the thing over, it would be 3 over 2, right? So here, the derivative of ln of x is 1 over x. So we would think of it as just the reciprocal. So then the derivative is, the reciprocal means to flip the function over. So it would be x squared plus 1 to the third power divided by 2x. But it is a composite function, so we have to multiply by the inside derivative. Multiply by the inside derivative, which is a quotient rule. Okay, so then the derivative of the inside require you to do a quotient rule. And the quotient rule said the derivative of the first, which is 2, multiplied by the second, which is x squared plus 1 to the third power, minus the derivative of the second, which is 3x squared plus 1 to the second, multiplied by the inside derivative of that, which is 2x, and then multiplied by the first, which should be 2x, all divided by the denominator square. So that would be x squared plus 1 to the 6th power. So that is the inside derivative. And then from here on, we'll just have some fancy algebra to work with, right? So you can see that x squared plus 1 to the third, x squared plus 1 to the 6th, this is multiplication. So I can divide. So at least I can say that this part right here is going to, that part right there is going to be 1. And this right here becomes to the third power because 6 minus 3 is 3, right? So, and then here we would go ahead and reduce and clean that up just a little bit. So I'm just going to go ahead and rewrite that here. So I will have dy dx dy dx is going to equal to, on the denominator we have 2x squared plus 1 to the third. On the numerator we will have 2x squared plus 1 to the third minus 2x times 2x is 4x squared, and then x squared plus 1 to the second. And we can see that we have x squared plus 1 to the third, x squared plus 1 to the second, and then x squared plus 1 to the third. Well, we can divide out x squared plus 1 to the second power. Okay, so when we do that, we will get on the denominator, you have 2x times x squared plus 1. You have 1 copy left. On the numerator, you have 2 times x squared plus 1 to the first power, which I can distribute the 2 to get 2x squared plus 2. And then this whole thing is gone, so I will have minus 4x squared. So then finally, the answer would be 2x squared minus that is negative 2x squared. There's a 2 on the denominator, so I can divide out the 2 as well. So that would be 1 minus x squared over x squared plus 1 on the denominator. And that is my final answer to dy dx. And that is it for number 6. Now, can you cancel the x squared from there? Oh, no. No, cannot, because it's addition and subtraction here. You can try to factor, but that's not going to be helpful. Okay, and so that is it.